Say it again?
Where are you drawing what? Where that
The velocity, if I had to draw the velocity time graph, I know that the graph has to be straight with a slope of 5. It's a positive slope. What would the velocity, Elaine?
5 meters at 1 second, and then 10 meters at 2 seconds, 15 meters at 3 seconds.
So you're starting to, that's what you're doing right there? Where this
No,
would
it'd
be.
No, it'd be more rectangular to the up. Like, go to the right one and up 5.
The right one up 5.
Yeah, up 5.
Are you suggesting the graph is a step function?
No,
Or
like-
just that fact that if that's 1,
And
that's
then
5?
Yeah, and then,
If that's 10, this would be,
5 times 10, 50? That- That's not right, is it?
all right. There is an issue with this.
Because it'd be more rectangular, the thingy would be more taller and skinnier.
Oh, now I'm with you.
Yeah.
I'm just not using the same scale on the axes. But yeah, that goes up 50 whatevers and that goes over 10. But that's not the issue. Because I'm establishing, specifically what the numbers are. Just imagine, if you wanted to do the same scale, then just imagine it's a lot steeper.
Flip it around.
Pardon?
Make it go that way, right?
No, it is sloped correctly.
Would it start at 5,
Why?
going through the origin?
Is there a problem going through the origin?
That's not what.
Yes,
Okay.
I was thinking.
Why go through, start at 5?
because that's the starting point.
Not necessarily,
Does change in
but
displacement.
it's almost there. Pardon?
Change in displacement over time. When you're talking about velocity, you're talking about your starting point, not your origin.
Okay, so what's the problem here?
Well, oh, that's right, I see it's below the top there. I don't have an answer.
Kimberly?
You use the slope to start the other line over the velocity line?
I use the slope to start the other line.
That's the slope, then that's where your line starts for the velocity line?
Oh, you're saying it should start at 5?
Yeah.
Yeah, not for that reason. Or, no, not at all. This is very similar to the question I asked before.
Should it be a little bit curved?
No,
Yeah,
not an
okay.
issue with that. Because my acceleration is constant,
Yeah,
the slope
that's
needs to be
fine.
constant.
So it's a constant acceleration and it starts at 5 meters per second squared. Right? Or meters per second?
My acceleration starts at 5 meters per second squared and stays there.
Right. So if it starts at 5 meters per second and it stays there, then.
The 5 meters per second squared, that's my
Okay.
acceleration. Which means my velocity changes 5 meters per second every second.
After, okay, never mind.
All right, Lacey?
It was started at 5 meters per second for the velocity because it started at 5, it didn't start at 0, it started at 5 for the acceleration for meters per second squared. Because you were saying like it starts at 5 meters per second squared for acceleration.
Correct.
So if the velocity started at 5 meters per second, that's just saying, because you said it goes up 5 every meter per second squared.
It goes up 5, velocity changes by 5 meters per second every second.
Yeah, so would it start at 5 because it never started at 0, it started at 5 and it kept going consistently at 5? Like adding 5 more, if that makes sense.
you're still, saying it starts at 5 meters per second is not necessarily true.
In the first 5 seconds.
Say it again?
Within the first 10 seconds, and it reach 5 meters. That's why we shouldn't be saying that.
I gotta be careful with the wording. After the first, what happens after the first second?
I was about to say, after the first second, it went to 5 meters. No?
So it
5
would
meters
be
per
like,
second.
it would be like a spike, right? Cause it would start at more 0 for 1 second, and then it would spike up to 5, and then be constant.
Oh, no.
No?
No, what I heard there was that you were picturing the graph doing
Yeah.
like that. If this is my velocity time graph, what's the slope of a vertical line there? What's the slope of a line that goes straight up? No, 0 is this way.
One.
The other one is like that. The other extreme? Somebody say it. If you were facing a cliff and the cliff looked like that, what would you say about the slope?
At 90 degrees?
At 90 degrees, that's generally not how you would express the slope, but say, yeah, okay. 0 slope, infinite slope. If the velocity time graph had a line like that, that would kill anything that experienced that would just get splatted. I suspect that the atoms would even get splatted. They wouldn't even maintain integrity. Matter of fact, if this actually were reality, would you get a nuclear explosion? No, they probably wouldn't even survive. I don't think that would happen. All right, so Rihanna, then Kimberly.
Two questions. First one, so the first velocity graph you drove through, is that line correct?
Is this, there's an issue with this.
Okay.
That,
And same question, what is the exact question we're trying to answer?
what's the issue with this?
Okay.
Now, the most common answer has been the fact that it should start at 5. And I said, not necessarily.
So there's not an issue with it, or there is?
So-
I'm sorry, is there an issue with it? Or-
Yes, there is an issue.
Okay.
The fact that the line's going up like that is not an issue. Yeah. Okay, Kimberly, did you have input? All right, Luis?
Okay, so that, the thing we were just discussing, the infinite slope,
Oh.
would that be considered a wall, since it's like basically straight up?
In a sense, there are times in which you get graphs like that, which you can easily go, imagine that's a wall, if that works. It would be anything that changes your velocity instantaneously. I guess a wall is if you're going in that direction, because then you would potentially just stop. This one, suddenly you're given an infinite amount of boost. Kimberly?
Is it wrong because like that is when it eventually speed up?
Keep going. What are you saying?
Like since it's going into the positive direction,
All right, we are speeding up here.
and then its acceleration is constant.
That's not an issue in and of itself. How do we know are we speeding up here or slowing down or neither? It's constant acceleration. It's not constant velocity. Constant velocity would have an acceleration on 0. All right, it might be time just to put a stake through the heart.
I do not have an answer for you, I'm sorry.
If all right, so constant acceleration here. So acceleration is positive 5 meters per second squared, which is the same as 5 meters per second per second. So my velocity is going to change by 5 meters per second every second. So if my velocity and time So at time 0, velocity is 0, after 1 second, I'm going 5, after 2, it's 10, after 3, it's 15, and so on. That's what we have plotted here. At time is equal to 0, suppose velocity is, we'll just make 7 meters per second. After 1 second, what's my velocity?
14. What did you, I don't know.
Assuming the same acceleration.
Oh, 5, okay, 12.
Seventeen.
And then 22, and so on. My velocity changes by 5 meters per second every second here. It changes by 5 meters per second every second here. If I'm going negative 20 meters per second,
Negative 15. Negative 10. Negative 4.
my velocity is changing by positive 5 meters per second every second. All 3 of these cases have the exact same acceleration. All 3 of these cases would have acceleration expressed by this. The first one is this graph. The second one would be something that looks kind of like that. And the third one looks something like that. A trick question is similar to the other one. My acceleration doesn't tell me velocity, it tells me change in velocity. Just like velocity doesn't tell me position, it tells me change in position, or displacement as we call it. Yeah, I might have let that go on too long. Sorry about that. There's that struggling with it and it has more meaning, or struggling with it to the point where you just drift off. So why don't we take a break here, come back, see if I answered Brianna's question. We started us all off on just going over this stuff. Stretch legs. Whatever. As we last left off. All right, so what started us down this path was the desire to at least go over the graphing aspects of it. And I guess you started with that. Did you want more? I mean, not necessarily more of what I've done, but something different, probably better wording.
No, I think I'm good.
Okay. I guess you'll find out on Monday.
Yeah, pretty much.
Well, now that LaToya's not here, here are the answers to All right. Other questions on chapters 2 through 5?
I might have some, like, after I get my papers back and realize that I'm very wrong about something.
Okay.
Same.
So hopefully I'll get to a point where I'll hand them back, not at the very end.
Okay.
Yeah, because we got a long time just to get energized, pumped up, take on the world. All right, I'm going to talk a little bit about momentum then, if there are no other questions. And hopefully this will clear up some things about that. I'd like to get into energy, but we'll find out where life takes us and if I need to adjust the schedule. Momentum. And actually, since I'm starting a new topic, let's just make life easier for posting.